We're about to take a look at some virtualization technology that's called Lisp. Well, what is this about? Find out next, right here on IT Pro TV.
You're watching IT Pro TV.
The very fact is we have some issues with the current address space that we were running, even if it's IPv4. And here to help us to actually understand the technology that will help us to manage that even better is going to be Anthony Sequeira. Anthony, welcome to the show. And
thanks so much.
Let's take a look at this idea that we call Lisp. A lot of times when people aren't familiar with it, they just say LISP, and but we generally call it Lisp, right?
Yeah, Lisp is what we'll typically call this. This is something that I remember studying like a decade ago.
Right.
And I was like, okay, cool. This would be useful in a mobile environment. And then I forgot all about it. Really.
Right.
And then, like we've been discussing here at Encore, it's really interesting how many of these technologies catch on again. This is definitely one of them. And it has a very specific role that it could play for us, Ronnie. And we'll tell you why in this episode inside that SD access solution. So with this Lisp and with VXLAN, we're going to be very biased to the application inside of SD access. Keep in mind, there's other great utilizations of these two technologies, but remember, we have the bias on SD access because that's one of our major topics inside of our Encore show. So here I put together a list. This has kind of been a theme, right? We start with, all right, what's going on in the current state of the network that would necessitate us making improvements like this? Well, when you think about your access layer today, isn't it amazing how dense, and no, I'm not picking on its intelligence. I'm talking about the number of devices. It's amazingly dense these days, isn't it? Right. You know, I sit next to Ronnie, and Ronnie and I have workstations connected. We have our iPads connected. We have our phones connected. We have our Kindles connected. It's just incredibly dense. Ronnie's has an IP phone connected. So it's remarkable. And Ronnie and I are running all over this facility with these laptops, going from studio to studio, meeting room to meeting room, break room. Sometimes we'll bring the laptops. So we have that mobility. We have the desire to segment. Oftentimes you'll take your, research and dev team and you're like, okay, I don't care where they go in this enterprise. They need to be in their kind of quarantine segment with the stuff they run on their laptops. So how do we implement this today? Well, it's messy. There's this whole stack of services is the language that Cisco uses. You've got RSTP. You've got your multicast infrastructure. You've got the routing infrastructure that sits on top. You're just stacking all of these different services up to try and provide all this functionality. So enter the SD access solution, and we've discussed that with its concept of an underlay and an overlay. Okay, let's talk about the underlay for a minute. It turns out that this is where we don't need a new technology like Lisp. No, the underlay begs for the traditional, what we call push model of information sharing, and that's a routing protocol. Notice that's the recommendation, not a layer 2 like RSTP, because we know that's going to have links that aren't utilized. Let's get all of the links active in the underlay by going with the routing protocol. Something like ISIS is a great idea. We mentioned this in our SD Access show because it's very flexible when it comes to carrying different traffic forms. Remember, intermediate system to intermediate system is like, I don't care what you want me to carry. IPv4, IPv6, doesn't matter. It's built very much like BGP was built in that it is multi-protocol right out of the box.
Now, as we continue to go through this, and you just used a term that maybe we might not be familiar with, the idea of that push. So an example of a push for us, if we were running something like OSPF, is that we see those announcements as we form adjacencies and they're pushing the idea of the routing updates out.
That's right. And Ronnie, we can deal with the push paradigm in the underlay because think about the underlay. It doesn't change that much.
Right.
There is not a lot of changes occurring in the underlay. I mean, think about it. There should be none.
Right.
Really. You're setting up the gear, you're setting up the subnets, and it's done. So you have something like intermediate system to intermediate system, which is helping you, route the traffic and stuff, but it's just very, very stable. There isn't, oh, we need to add 10 new subnets every Friday. Those kind of frequent changes aren't taking place. So that push model, that underlying routing protocol, great for the underlay. Now let's move to the overlay,
right,
because things all of a sudden change dramatically based on what we were discussing at the top of this episode. We have all of these gadgets, many of them on our person, and we are moving all around. Oh my goodness, there is a ton of change that we want to accommodate in the overlay. So we need a new model, a new overall approach, and this is where a pull situation is going to be much more effective. The common analogy here for what we're going to do in the overlay with Lisp, and I really like this analogy, it's rock solid, is DNS.
Okay.
Think about DNS where you're like, hey, where's www.itpro.tv? Where is that? And DNS goes, here it is. We are going to use that type of a pull model with our tracking and our location information for all of these densely populated endpoints. So we want a mapping protocol, not really a routing protocol here in the overlay. And Lisp, with some modifications that Cisco has done, becomes the ideal solution. Think of it as a simple, really fast database of endpoints. That's really what we're dealing with.
Yeah, so this is kind of neat in the very fact that most of us who come from the CCNA, we probably haven't heard the term push or pull model like using with routing protocols. We just tend to say, oh, they're updating, they're talking to each other, They're doing this kind of thing. So when you talk about a pull model, what we're saying is we're not really doing that. We're actually going to request it when we need it, just like DNS.
That's right.
To make that connection. So to a point that's a little bit less noisy. Is that?
Yes, very much so. Yeah, you're going to see how remarkably efficient this is.
Yeah.
Yeah.
Yeah. So in that sense, when we start doing this, how does Lisp then fill in the gaps and do what we need to?
Yeah. Ronnie, let's take it step by step. Like, let's really break this down. This is how it's funny because it's like, oh, this show's going to be 30 seconds long because this is simple by design. It's a beautifully simple thing. The host right here connects to the access layer. And these devices are Lisp capable. We make sure that we have Lisp as the overlay technology. So this device that it attaches to, we give the lowercase x, capital T, capital R verbiage to. That is a Lisp tunnel router.
Right.
I love how it's funny. We use the router term there, even though this is an access layer device. It's certainly like a switch, but of course we know we're pushing layer 3 routing intelligence right to the edge. And what's really funny about that is we're not routing here. We're using Lisp, which isn't dependent on the routing table. But anyways, just bear with me on the language. It's the XTR that says, oh, hello there, little host. And by the way, we can make sure there's security here. Remember, we can have the identity service engine ensuring that this laptop is permitted to join this network. So this honors security. So it says, oh, okay, let me go ahead and register you with the Lisp database. Now, notice I have MAC or IP here, Ronnie. We could be doing this in a layer 2 design. Then we would be grabbing MAC address. But what is much more common, as we've emphasized, is we deal with layer 3 right to the edge. And so we grab the IP address of that device, and then it takes that traffic, it takes that registration, and it sends it up here to the Lisp mapping database, which exists on this device upstream. So what we have is a map register entry, and it has an EID, endpoint identifier, I believe, and then an RLOC. If you could tell us what that stands for.
Router location.
Router location. I always just call it the RLOC. So in this map register information, we have the IP address and the VNI. That's the virtual network identification. That's the VXLAN info. So you see it's IP address and the VXLAN info. And then the RLOC is the IP address of that Lisp tunnel router. So there's this information in the mapping database of where that host is. And guess what? To make this lightning fast, even though it's already super fast, you have a map caching that can take place. So it's like, oh yeah, where's that endpoint? It's right over there off that device. And I can tell you right out of my cache. But this is where it gets even more exciting. What happens when we have a move? So Ronnie takes his laptop, unplugs it from where he is, goes over into the classroom space here, one of our classrooms on site, and he plugs in there or gets on the Wi-Fi there. Well, the new Lisp tunnel router goes, oh, hey, there he is, and registers that new location. So there's this immediate cutover of the database information for Ronnie's location, and his peers that want to communicate with him can check the mapping database and find out where to send the traffic immediately. And I know if this is the first time you're seeing this, it's like, holy mackerel, as my father used to say. This is a whole new world.
Yeah, this is kind of one of the harder concepts, at least conceptually, if they haven't seen it or understand it, they're going to run across. So it was kind of neat the first time I heard about it and tried to try and figure this out. My device still has an IP address, but it's not used essentially for locating that device. That IP address is only for identifying that device as being unique. Whereas the RLOC is, I think I said it wrong, it's not router, it's routing locator or location. So that is actually the IP address that as we go across networks and stuff, it says, here's the IP address we're looking for, but that specific device is going to be actually with that EID, that locator ID is what's going to happen here. And to a point, as you were going through it, I was starting to actually think about the idea of the ARP table a little bit, where it actually matches the MAC address to an IP address, but this time it's RLOC to that EID number instead. So it's sort of mapping like that.
Yeah. Think about any mapping database, and that's what we're dealing with here. And it's really interesting. We are so biased towards routing.
Right.
And so this is not the traditional routing that we're used to. So it is a paradigm shift.
Yeah, and it's kind of neat because I guess as the world continues to move towards this software-defined networking situation and access, it's going to become more important, if not trying to assign individual IP addresses that give us both the location as well as the identity. That's where it becomes a mismatch. And so this is one of those technologies that really kind of helps separate that out.
Yes. In fact, you're giving the words that we should look up unless you have them memorized. I always call it Lisp.
Right.
But that's spelled out. That's location.
Nope.
Yeah, look it up.
All right.
It's talking about the separation of the identifier and the location information right in the title.
Yeah.
So Ronnie will find out what Lisp stands for. I meant to put it on one of our visuals here in the episode, and I failed to do that. But So just be ready to really be flexible with your mindset about how we're going to move traffic.
Yeah, I've forgotten. My mind blanked as well. It's locator ID separation protocol.
Locator ID separation.
Right.
Yep. Protocol, Lisp.
Yeah, so it's actually kind of a very neat technology that you're going to find more and more. So the idea of just an IP address itself is not really, as far as individual devices go in SD access,
Yep.
really about locating. It's about just identifying it inside of,
That's right. And, by the way, this isn't the first time we've had to really open our minds, right? This reminds me a lot of MPLS.
Right.
Where it was like, oh my gosh, wow, that was loud. It's like, oh my gosh, there's a whole new way to move traffic. And it's involving these little labels instead of IP addresses and prefixes, So this isn't the first time we've had to be like, oh, wow, there's a whole new paradigm here at work. So this really does remind me of MPLS in that way.
All right, Anthony. Well, thank you for helping us to at least get started and understand more about the idea of Lisp here. It is a technology that you're going to run into, especially with SD access. You're seeing a big push towards this, and it's actually used, Anthony's told you this dynamic nature of how we can actually shift and be able to locate devices much faster as well. So some of the terms you want to be familiar with are the terms that Anthony also listed, that XTR. Make sure you know what that device is, as well as the term EID and RLock. Those are actually going to be vocabulary that I think you're going to absolutely need to make sure that you do understand what those devices are. Well, there is more to come, but that's enough for this episode. Signing off for IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your CCNP Encore show.
Thank you for watching IT Pro TV.